Hello, my dear student. Welcome to another edition of your mathematics lesson. Today, we're going to take the fourth theorem under this main topic, cycle geometry. We're going to take the fourth theorem. So let's begin. After completing the very lesson today, my dear student, you'll be able to identify what we call a cyclic quadrilateral. After that, you also be able to find the measure of the interior angle in a cyclic quadrilateral. These are the two things I hope you'll be able to do after completing the very lesson today. In your favorite segment of the lesson, my dear student, Maths is fun. Today, I will explain what happens if you are to add any 2 or 3-digit integer plus it is reverse. What happens? I will explain what happens after completing my lesson if you stay with me. So let's move. To begin the lesson, my dear student, let me first explain what is cyclic quadrilateral before we jump into this theorem number 4. So cyclic quadrilateral is a quadrilateral with all it is 4 vertices lying on the circumference of a cycle. If you have a quadrilateral that all the 4 vertices of that quadrilateral are on the circumference of a cycle, then the quadrilateral is called a cyclic quadrilateral. Let's just see it in drawing. If you have this cycle, and you can see this quadrilateral, it has 4 sides, and you can see this 4 vertices, 1, 2, 3, and 4 are all lying on the circumference of the cycle. Then this quadrilateral is called a cyclic quadrilateral. But when we come to this very one, you can see 1, 2, 3 vertices are on the circumference, but this 4th vertex is at the center probably of the cycle. So this will not be a cyclic quadrilateral because all the 4 vertices are not on the circumference. As you can see, this 4th vertex is not on the circumference. So this is what we call cyclic quadrilateral. So our theorem number 4 is basically on the cyclic quadrilateral. Let us just move and see what is theorem number 4. So theorem number 4 says opposite angles of a cyclic quadrilateral are supplementary. Supplementary simply means add to get 180 degrees. This is the drawing, and you can see a cyclic quadrilateral here, and with the angles alpha, theta, gamma, and beta. So what this very theorem is saying, if we are to find out 2 angles that are opposite in a cyclic quadrilateral, just like alpha and gamma are opposite, theta and beta are opposite, and this quadrilateral is a cyclic quadrilateral. So the addition of the 2 opposite angles gives you 180 degrees. This is what this theorem is telling us. So from this drawing, the angle alpha and the angle gamma, if you add the 2, what you simply get is 180 degrees exactly. Similarly, if you add the angle theta and the beta, you also get 180 degrees. And the reason whenever you make this assumption, what you now write as reason is opposite angles of a cyclic quadrilateral. This is the fourth theorem, and this also is going to be very, very useful while solving cycle geometry problems. Let us just move and take examples. Example number 1, you asked to work out the marked angle. The marked angles in this very drawing are alpha and the angle theta. Solution to this very problem. So looking at the drawing, it's a cyclic quadrilateral because I can see these 4 vertices all lying on the circumference of the cycle. So from the theorem that we have just learned, you now identify the angles that are opposite in this cyclic quadrilateral. So the addition of those 2 opposite angles will give you 180. Let me just begin with the angle theta. Angle theta and the angle 70 degrees are opposite to each other. Look at it. I colored the angle theta yellow. The angle 70 degrees is colored green. So the addition of theta and this 70 degrees will give answer 180. Because of this, the theorem says opposite angles of a cyclic quadrilateral are supplementary. Supplementary means add to get 180. So I can take 70 degrees to the right hand side. There I'll have my theta to be equals to 180 minus 70. Subtracting 70 from 180 correctly gives you answer 110 degrees. So the size of this angle theta is 110. So you now move ahead and find the angle alpha. Angle alpha and the angle 108 degrees are opposite also. So the addition of alpha and 108 will give result 180 degrees because the two angles are opposite angles of a cyclic quadrilateral. So taking 180 to the right hand side becomes minus, so you now have alpha to be equals to 180 minus 108. Subtracting 108 from 180 correctly gives a result of 72 degrees. So the size of this angle alpha is now 72 degrees. Let us just move and take another example. Example number 2 says in the diagram, the angle QSR is 62 degrees. It is marked also in the drawing. And the angle QRP, look at it. This is the angle is 37 degrees. Is also marked in the drawing. So what the question asked to find is to find the size of the angle PQR. PQR, this very angle, look at it. Solution to this very problem. What I'm going to do first is to mark the angle asked to find, that is angle PQR, this very angle. Let me just mark it. Look at it. It is this angle that we asked to find. So what you now do, you look at the given angles and think of the theorem that you're going to use, either this, the theorem of other theorems that you have just learned. In the end, it will enable you, or you'll be able to find this very angle PQR. So looking at this very arc PQ. So theta angle 37 degrees at the remaining circumference. And the same angle PQ, so theta angle S, look at it. This angle at S. I colored these two angles green, look at it. One of the theorem we have learned in one of our previous lessons, angles obtained by same arc and on same segment, those two angles are equal. So this angle is now going to be 37 degrees, and the reason is angles on same segment. This is one of the theorem we have learned in one of our previous lessons. So if this is now 37 degrees, let me just write it. I can now add 62 and 37 to get this angle PSR. And angle PSR, the whole of this angle, look at it, is opposite to this angle at Q. Look at this angle we marked, the angle that we intended to find. This is a cyclic quadrilateral. So the addition of the whole of this angle together with the marked angle will give a result 180. So let me do that. So addition of the angle PQR. PQR is the angle asked to find. And the sum of these two angles will give me result 180 because the whole of this angle and the angle PQR are opposite angles of a cyclic quadrilateral. So addition of those angles will give result 180 degrees. So I'll now take the sum of 62 and 37 to the right hand side. There I'll get my angle PQR to be equals to 180 minus the sum. So 62 plus 37, I'll subtract that result from 180. If that is done correctly, you now have 81 degrees. So this marked angle PQR is now going to be 81 degrees. Let us just move and take one more example. Example number 3 says in the figure, this line PQ, look at line PQ. It is a diameter. You can see it passes through the center. So line PQ is a diameter. And angle RPQ is 29 degrees. Angle RPQ, look at the angle is marked also in the drawing, is 29 degrees. So what we asked to find is the size of the angle PSR. PSR, it is this angle that the question is asking us to find. Solution to this very problem, what you do first is to mark that very angle asked to find so that you now concentrate only in the drawing. It is this angle that we wanted to find. Let me just mark it. This is the angle that we wanted to find finally. So what you now do, you look at what is given and think how you can now use the information available to find this very angle. And this angle PSR, looking at it, I can know where I can now connect this angle and this given angle 29. So what I would think of doing is drawing a line from R to Q so that I have a cyclic quadrilateral. Let me do that. So I call it construction. So in the construction, meaning addition of another line that is not a part of the given question. So what I'm adding is now line QR. Line QR from Q to R, you now draw a line, and that is usually done in dotted line. The construction line is usually done in dotted line. You are just adding it so that it gives you way out, so that you can move further. So having done that, what you now do, you look at the drawing again, look at this very drawing. This PQ, it is a diameter, and that diameter subtend angle PRQ at the semicircle. So this very angle PRQ is now going to be 90 degrees. We learned this in one of our previous lessons, angle in a semicircle. So the angle PRQ, this angle, look at it, is now going to be 90 degrees, and reason is angle in a semicircle. So this is 90 degrees. So what you now do next is to find the angle at Q, this PQR. If I look at this triangle, I have two angles, 29 and 90 degrees. So I can use the two angles to find the third angle using sum of angle in a triangle. Let me do that. So angle PQR will simply be equals to 80 minus 90 minus 29. And the reason is angles in a triangle. So subtracting 90 and 29 from 180 degrees will give you this angle as 61 degrees. So this angle at Q is now going to be 61 degrees. And looking at this angle 61 and the marked angle, that angle we asked to find, they are opposite angles of a cyclic quadrilateral, because PSRQ is now a cyclic quadrilateral. So the addition of 61 and the marked angle will give answer 180. Let me do that. So you now have angle PSR plus the angle 61 degrees. That result will now be 180, and the reason they are opposite angles of a cyclic quadrilateral. So taking 61 to the right hand side, you now have a PSR to be equals to 180 minus 61. Subtracting 61 from 180 correctly gives a result 119 degrees. This will now be the marked angle. With these few examples, my dear student, I have come to the end of this very lesson. Let me just move quickly to the last segment, Maths is Fun, where I promise to explain what happens if you are to add any 2 or 3-digit integer and it is reverse what happened. So it says every 2-digit integer plus it is reverse will lead to what we call a palindrome number. Similarly, every 3-digit integer, if you are to add it with the reverse of that 3-digit integer, what you're going to have, the addition, if you continue to do it, it will lead you to what we call a palindromic number. Palindromic number is the number that is exactly the same with it is reverse. So let's take examples. Starting with the very first number 37, add to it is reverse 73. If you are to add 37 and 73, you can see 37 is a reverse of 73. What you're going to have is 110. This is not a palindromic number. So what you now do, this 3-digit number 110, you also reverse it and add the two numbers. So you now have 110 plus the reverse of 110, which is now 0111. If you add 110 and 11, what you are going to have is 121. You can see 121 is a palindromic because this 121, if you are to write it as reverse, it will be exactly the same 121 you are going to have. Let's take another example, 605. It is reverse will now be 506. If you add this, you now have 1111. This is a palindromic number. If you are to write it is reverse, exactly is this that you're going to have. Let's just take one more example. 87. It is reverse will now be 78. If you add 87 and 78, what you are going to have is 165. This is not the palindrome. So you now reverse this number again and add. So 165, it is reverse will now be 561. Adding 165 and 56, what you are going to have 1326. This is also not palindrome. So now find it is reverse also. So the reverse of 1326 will now be 6231. Look at it. If you now add 1326 and 62231, you're going to have 7557. You can see 7557. If you are to write it as reverse, it's exactly 7557 you are going to have. So which means 7557 is a palindrome number. So this is what happens when you take any 2 or 3 digit number and add to its reverse. If you continue doing that, it will eventually lead you to this palindrome number. We'll see more of this amazing things in mathematics in our subsequent lessons.